So to talk about z-scores, I just want to go through one more example of how z-scores map onto the different standard deviations away from the mean that we've already talked about. So right now I'm going to draw out both the general version and the example version of number of thefts of the normal distribution. So here we have our mean. We have our mean down here as well, and 1, 2, and 3 standard deviations. I just imagine that they're all the same distance from each other. Okay, so we have our mean plus 1 standard deviation, our mean plus 2 standard deviations, and our mean plus 3 standard deviations. Again, mean plus 1 standard deviation, mean plus 2 standard deviations, and mean plus 3 standard deviations. And these all are single expressions here. Okay. So what I said before is that a z-score is the same thing as how far away you are from the mean in standard deviation units. So in this case, we'd say that the mean plus 1 standard deviation is 1 standard deviation away from the mean. The z-score then is going to be equal to 1. Let's say we want to think about 3 standard deviations away from the mean. So here we're counting in standard deviations. We'd say we're 1 standard deviation, 2 standard deviations, 3 standard deviations. So our z-score is going to be equal to 3 over here. And then as one more example, let's say we want to look at 2 standard deviations. Oh no, this is all say minus and not plus. So here, one of these days, so if you find any more mistakes on here, again, extra credit if you find one. So we've got our mean minus 1 standard deviation, our mean minus 2 standard deviations, and our mean minus 3 standard deviations here. So let's say we want to know the z-score for mean minus 2 standard deviations. Well, we're 1 standard deviation in this direction, and we're 1 standard deviation in this direction. Again, a z-score tells you how far you are away from the mean, counting in standard deviations. So here we'd say that our z-score would be equal to -2 for the mean minus 2 standard deviations. So we're just counting in standard deviations. You can also apply z-scores to values when you have numerical values plugged in. So here's our number of thefts. I'm going to write out the values we had for 1, 2, and 3 standard deviations away from the mean. So we had 80, 95, and 110 here. We had 50, 35, and 20 here. So we can find a z-score for these values also. And I'll do the same example. So let's say we want to look at 1 standard deviation away from the mean going in the positive direction. Our z-score here is going to be the same. So z is going to be equal to 1 for 80 thefts. Let's say we want to go 3 standard deviations away from the mean. Our z-score for 3 standard deviations away from the mean, in other words, 3 hops of 15, this is going to be equal to 3. So it's the same thing that we have on this more generic example here. Now we're just saying that the z-score for this particular number, so the z-score for 110 thefts is equal to 3. The z-score for 80 thefts is equal to 1. And then finally, let's say we're going to go 2 standard deviations in a negative direction. Well, we know we've made 2 hops of 15 in the negative direction, so our z-score for 35 thefts is going to be equal to -2. And I'm just going to put boxes around the ones that I actually have z-scores written out for, just so that you can distinguish them a little better, because I know it's kind of a busy picture here. So our z-score for 110 is 3, our z-score for 80 is 1, and our z-score for 35 is -2. And again, what the z-score tells you is that for 80 thefts, you are 1 standard deviation away from the mean. So you have 1 standard deviation move away from the mean in the positive direction. For 35 thefts, you have a z-score of -2, and that tells you that you are -2 standard deviations away from the mean in the negative direction. The nice thing about z-scores, though, is that you can find them for any value. And in order to find a z-score for any value, you're going to use the z-score formula. And our z-score formula is going to look like this. z is equal to x minus mu over sigma, where x is some value, mu is your mean, and sigma is your standard deviation. So I'm going to redraw the graph for thefts in a store here again. So our standard deviation is 15, our mean is 65. Another note for those of you at home, I will always give you the mean and standard deviation for a normal distribution. You'll never have to calculate it ourselves. So numbers like this, the 65 and the 15, will always come in the problem itself. It will be provided. All right, so let's say we want to find a z-score for 60 thefts. And in other words, we want to know how many standard deviations away from the mean is 60 thefts. If you were to count in standard deviation units away from our mean of 65, how far do you have to go to get to 60? So in order to find this out, we're going to plug these values into the z-score formula. So for 60 thefts, our value that we're interested in here is 60. So we want to know our z-score for a value of 60. So we're going to plug in 60. And then we're going to plug in the things that are already given in the problem. So we know that our mean is 65. We'll plug in 65 for the mean. We know that our standard deviation is 15, so we'll plug in 15 here. And again, I'm using this formula here to plug in these values. Now we just have some simple math. So if we subtract on top, we get negative 5 over 15, and this gives us a z-score of negative 0.33. So we have a z-score of negative 0.33. What does that mean? What that means is that we're moving negative 0.33 standard deviations away from the mean towards the left. And you should be able to see this on the graph as well. So our standard deviation is 15. We're moving 5 thefts to the left, and 5 is a third of 15. So what you're seeing here is a third of your standard deviation, or 5 thefts to the left. We can also find z-scores for other values, so I'll just go through one more example here. Let's say we want to find the z-score for 100 thefts. We want to know how many standard deviations away from the mean 100 thefts is in this example. So I'll put a line here for 100, and we're going to find the z-score for 100 as well. So I'll also write z is equal to negative 0.33 here. Now we want to know what z is equal to for 100. We're going to follow the same steps. We're just going to plug in our value for x, which is 100, then our mean, which is 65, and our standard deviation, which is 15. And again, mean and standard deviation are given, and you're just plugging in that value for x on the top. If we subtract this out, you get 35 over 15, and this comes out to a z-score of 2.33. In other words, our 100 thefts here are 2.33 standard deviations away from the mean going in the positive direction. So it's 2.33 jumps of 15 away from 65 in order to get to 100. And so now you know how to find a z-score, and I'm going to go back to show you what these z-scores are used for.